Good afternoon, everybody, and welcome to this interview with Vincent Steinmetz. This interview will cover human-machine interaction and focuses on the role of safety in the development of new innovations. Vincent, good afternoon to you. Thank you for joining
Hello.
us. Would you be so kind to introduce yourself?
As you said, I'm Vincent Steinmetz, and in my daily life, I have two jobs. First of all, I'm a commercial airline pilot, flying a short-haul operations. And besides that, I'm also a safety investigator, and I'm running a company, or I'm a partner and consultant in a company in which we conduct safety investigations, but also train new safety investigators and help companies with implementing and designing safety management systems. My background is aerospace engineering, and I have conducted the studies in human factors and system safety.
Thank you very much, Vincent. That's very interesting because we have quite a few questions about the interaction between humans and technology and innovations. So I'd like to start off, what does human factors mean to you, and how does this impact human-machine interaction?
Well, a very simple definition of human factors is the study between the interaction or interface between man and machine. And if you look to aviation, this is the starting point of flying an aircraft. What is the interface between man and machine? And can we as humans or as pilots understand what the machine tells us, or what kind of information it provides to us, and what should we do with it or what not? So it's very important to be able to fly safely from A to B. And this is how it impacts human and machine interaction. We are continuously and even progressively more busy with machines and computers, which become more and more complex. So a good interface is necessary for us to understand what is happening.
Exactly, and elaborating on that point you just made about the complexity of airplanes of today. For example, the A350 is an incredibly complex aircraft with the human and interaction interface. So how do we ensure that the interaction between pilots and the aircraft remains practical and effective?
Well, the short answer is that the pilot must understand what the aircraft does. So understand what is going through the mind of the pilot. If we look a little bit back for the earlier models of aircraft, because the A350 is now one of the state-of-the-art aircraft of today. But if you look back in the 20s, when the first aircraft for passenger transport were developed, they were very simple. You could very well understand as an outsider how this machine worked, because it was wood with fabric and steel and cables to steer the aircraft. And nowadays, the aircraft is mainly flown by a computer with huge amounts of software in the machine, which all comes together in a cockpit with a few fancy and very nice displays. So it's impossible nowadays for a pilot or a crew in a cockpit to fully understand how the aircraft is designed, how it is built, and how it is working, because it's too much knowledge to fit in one brain. So there must be very well thought about what information do you provide to the crew, and how do you do it. But there's, of course, engineers. They have a system of developing new technology and how to implement this in an aircraft. But to really understand how an aircraft is operated in a dynamic environment of an airport, in the air, under an operations of an airline, you need to understand what the pilots think and how the pilots act, or what they think of the information that is provided to them. So to ensure that the interaction between pilots and aircraft remains practical and effective is by understanding what the pilot needs and how he processes the information which is presented to him.
Right, and just elaborating on that, as a pilot, what are the challenges you see in your daily operations? Especially in relation to the human interaction interface with the information you get displayed to you in the cockpit?
Well, because the aircraft are more and more complex, and you can get loads of information from all kinds of sensors and systems in the aircraft, it's a challenge, I think, to determine what information is given to the pilot when and how. And also to get understanding of how the pilots use systems maybe differently than what they are designed for. A very simple example is that I know a crew who became lost comm. One of the systems on board failed, so they had no communications with the outside world anymore, or with the aircraft air traffic controller. And they also had to divert to another field. But how are you going to tell ATC that you're going to divert to another field than what you intended to? And so they used the transponder system. The transponder is the system for which the ATC controller can see what aircraft you are, what is your identity, and where you're flying to, and what transponder code you have. So he can distinguish you from other traffic. So they have changed their flight ID to divert to, for example, Amsterdam. Just div to Ams. You have 7 characters, and they have for your flight ID, for example, Martinez MP and then a flight number. They changed it to div to Ams. And so they used systems in a different way than where they originally designed for. And another example is where the system works against you. A beautiful example is, for example, the Qantas 32 incident departing from Singapore, where they had an uncontained engine failure. And the system worked as designed. They gave warnings and they gave all kinds of information about things that didn't work anymore. But the crew could not figure out what was exactly the first thing they should do. Of course, they should have shut down the engine, but the information which was presented to them was conflicting with each other. So they had to fall back on their experience of basic flying and their experience on what should we do, or how should we configure the aircraft to return to the field in order to get the aircraft back to the airfield. And in the meantime, all kinds of warning alarms and bells and whistles kept going on in the cockpit. So it was a kind of noise. This is an example, according to me, where the systems and the interface works against you. And this is valuable information for further developments in human-machine interface on, okay, if something happens which is outside the context of what we've designed the system for, how can we then take care of that the crew can still fly the aircraft and land safely at some airport. So with the human-machine interface, with the current design of aircraft, it has increased complexity. As I said, systems and software and all kinds of systems built in the aircraft has increased its complexity. It brings its own complexity with it. And second, it's very difficult to further improve the HMI human-machine interface based on things that are going wrong, because we're an ultra-safe system. So things that really go wrong is very little. Most of the time we have success. And another thing, what I think should be very important in taking into account with HMI is the experience. Nowadays, if my experience with testing new systems or validating new systems during their development stages, it's only based on quantifiable data. So as a pilot, I'm invited to test a system, and I have to assess a system and give them ratings and scales, and but nowhere is the question asked, okay, what is your experience about it? Or is it placed in a context of daily operations? I think that is very important, that also it's very difficult to quantify it. Experience and insights of crew who daily work with these systems, to take this into account in your design for your HMI.
Right, and that's actually what I wanted to continue on to. So my question would be, do we need to see a shift in the way human-machine interaction is used in the innovations of today, or maybe in the future, to ensure that we meet operational requirements from, example, pilots like yourself?
Yes, I think so. Most systems now are designed according to a technological readiness level. And the first step is basic technology research. and that is usually done by engineers in a company, and designing what is technological available possible right now. I think that the way we now design systems is good, but if we want to further increase safety in aviation, we need to add to this. And we need to add the human experience and the human insights of the people who are daily working with these systems. So to give you a little summary, right now, if we design systems, then the innovation is mainly technology driven. And if we want to achieve a performance improvements, we try to achieve it by reducing uncertainty and reducing errors. And mainly errors by people, because it's or technical failure or human error. And these are the two options which, according to some safety science, are the only two options for increasing safety. I do not agree with that, but that's another discussion. And the third thing, to achieve safety, we try to control risk, harms, and errors to an acceptable level. But in complex systems, usually 1 + 1 is 2, but 1 + 1 can suddenly be 4 or 5, and you never know when this outcome presents itself. So in complex systems, besides what I said, it's impossible for one person to have the whole system, the knowledge of the whole system in one mind. It is also possible that the outcomes will be something totally different than expected. And it's very difficult to anticipate that. So if you try to control that what you know, then you forget all other possible options of that outcome of these systems or operations or flight operations. So I would like to see in the future that if we considering HMI and how it can increase safety in operations, to change it in innovation is mainly driven by operational experience and insights. Just thoroughly know how an aircraft is flown, what is going through the minds of pilots, what do they need if something is going wrong. Because you will never see that something is going wrong which is according to your QRH, your emergency checklist, but something is going wrong which is not in the books. For example, I have had a flight in which I had engine vibrations, so the vibrations in the engine became too high, and there's a perfect checklist for it for one engine, but I got it in both engines. What do you do then? Because in the checklist says shut down engines. So there you're getting insight in the operational experience and insight what the crews do at such moments can help you to improve HMI in further aircraft design. Second, for your performance improvements, of course you have to look for systems where you can reduce uncertainty and or reduce errors. But it's very important that you can also improve performance by getting more insights in crew. So share experience and let crew share experience. And that's also why it's very important that if you start flying as for example, commercial pilot, that you start as a co-pilot to see what the person next to you is doing. It's on-the-job learning, and that's a very important aspect of flying safely. And as last, I think that new HMI designs or changes in interfaces should be done based on a safety definition in which it's a condition where multiple activities fit together and to bring out the intended outcome in an effective way. That is a quote of Eric Holnagel. And it's impossible to control everything what might going to happen. So instead of being risk adverse, we should be risk competent. Not knowing what is going to happen, but being able to sustain operations and try to fix the problem with the knowledge and the means and the systems you have at that time.
Then I just have a final question for you, Vincent, and it's based around the innovations that we are seeing within other companies such as Embraer is doing. How could we create a safety culture taking into account the human-machine interaction ideology that you just touched upon, which enables technological innovations?
I think that it would be, and of course it's a question if that's possible, but it would be very nice to mix more with operations between flight operations, and designing aircraft. In European projects I've worked in the past, the engineer said, okay, we sell aircraft of one of the aircraft builders in Europe, but we have no clue how these are used in operations. Of course, we write a book about procedures, how to start an engine and how to select flaps and everything, and how the FMS system works. But how it's exactly operated, we have no clue, or very little. And I think that is exactly the clue how you can create a safety culture in which you can enable humanistic technological innovations or innovations based on experience, is that to mix these with each other. Come fly with us. And the same is for the other way around. There is time spent during the development phase of systems, and crews are invited to have a look at these new systems. But I think that can be intensified. It will cost more time, but it can be intensified to really design and get a system at the end which is operational, which is intuitive for crews, and in which they can have put their experience and their expertise in how to use it. So it really helps them in any situation they encounter during their operations.
Right. So if I understand you correctly, what we should see in the future is a combination of the innovators of the aviation industry and the operational experts, such as the pilots and people from the airline industry or airport, to really create a better, safer, more innovative system.
Yeah, I think there should be more collaboration between operations and design, and know from each other how the design is made, but also how the design is used in operations. I think there could be more cooperation. The information is there, the experience is there, the expertise is there, but it should be combined.
All right, Vincent, that's all we have time for today. We're going to have to see what the future brings for innovation and safety, how we're going to combine those two. Thank you very much for your time.
You're welcome.